So people. Okay. Internet hates me. Wait 2 seconds. So, what is MAF? No math. Okay. Let me see if my internet works. No, it doesn't. What? What? The second it claims it's connected, but it doesn't. It's not connected. Interesting. The second internet is not my friend. Yep. Okay, you can see my screen, right? Everyone.
Yes, Khan.
ขอบคุณครับ Okay, you as well. Time is it? Okay. So what we're gonna learn today is to do more induction, right? I kind of left off at a very bad place last time. Induction is probably one of the most important technique in this class. So you're gonna get to do two homeworks on induction, which you're gonna become an expert. And as a reminder, homework one due on Thursday. And this thing is much harder than homework zero. For those of you who start already, can you confirm what I said? This thing is much, much harder than homework zero. Okay. You would like to try, thank you. Okay, this thing is much harder than homework zero, but by the end, I think you're gonna become quite proud in like how much you improve. You may spend like a lot of time on this homework, but you're gonna feel like you're smarter, but if you try to answer your parents, what exactly did you learn? You cannot really explain it to them. They don't have enough background to understand, unless they're like mathematician and so on. Okay, so you can even explain. At least make sure you explain it to your TA. Whoever gonna read your proof, not me. Let me see. What else do I need to say? So that means start now. Okay. So that means start now. If you haven't already, you should start it like last week. If you haven't started, start now. Okay. And also let me tell you about the homework policy. The homework policy is that I want you to learn. I don't really care how you learn it. As long as you learn, I'm good. Okay. As long as you learn how to write proof, how to explain it to yourself. By learning, I don't mean giving me the answer. Right? I want you to learn rather than just giving me the answer, because if you try hard enough, I think you can get the solution from your P and so on. But that's not the way you should learn, right? You should learn how to explain to yourself through proof, because if you get the spoiler, you're not going to learn anything. So please don't. If we finish and learn and don't trust any of our proof, so you're on the next level already, just it, right? The first thing that you learn how to prove, the next thing is to question your proof. So you're on the next level already. Okay, let's do this. Let me give you a quick review of what induction is, right? Induction is like dominoes, like last time. A lot of you confused. I think I did point out well enough that it was a metaphor. Okay, that to get all the dominoes to fall, right? By domino falling, that means the theorem is true for a certain number. Like this is 1, 2, 3, and 4, right? To get all the dominoes to fall, you need to do two things. You need to make sure that the first domino falls, which is the base case, right? Okay, and you need to make sure the second thing, which is you place the dominoes close enough to each other such that when one falls, the next one gonna fall, right? So that means you want to show that if k falls, then k plus 1 gonna fall as well. Any questions or any questions? Yeah, you kind of remember, right? That's the gist of it. We're gonna do this for like many classes. Okay, because there is a little bit more to it, but you're not gonna learn that exact thing today. Today you're gonna do some more simple examples. So let's try theorem. Second, let me make sure I did not screw up. Okay, so I want to show that 1 plus 3 plus 5 plus 7 plus dot 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 plus 2n minus 1. I put minus 1 here for a reason, right? Okay, so that means essentially you add up the odd numbers up to a certain point, right? Which I call that number 2n minus 1, because by now odd number can be written as 2n minus 1. Essentially, you can write as 2n plus 1, but that's the same idea. Okay, any guess? What's it equal to? Let's try, right? You want to know, you can do experimental mathematics. That's actually not a word, but I'm gonna say that. Okay, if you add up to 1, that's just 1. If I add 1 up to 3, right? So that's 4, which is, let me make sure that we are on the same page. So 2n plus 1, so that's 2 times 2 plus 1. So that n is 2. Oops, not plus 1, minus 1. Right? And then if we add up to 5, 1 plus 3 plus 5, that last guy is 2n minus 1. Right? So you get, what is this? 9. Good. And this thing n is 3. Let me do this. This thing n is 2, n is 1. Everyone is with me, right? And then I can do 1 plus 3 plus 5 plus 7, which is 16. And that's n equals to 4. And so on. I think this is long enough such that you see the pattern. What is it? Any guess? What is the sum of the odd number up to a certain point? the square of n, right? But we learned, right, that this is not a proof. You try for a number, it works, it's not a proof. That's good, right? You try for a number, it works, but it's not a proof. So we want to prove it that this thing works for all n greater than or equal to 1. Well, I can say all n in integer. That works too. That's good, right? So you want to show that this thing is true for any n from 1 to infinity and so on. Okay. So what do we do? What do we do? How do we prove this? How do we prove this? Any good idea? Base case, good. If you don't know what to do, you do the base case. But before you do the base case, right, you need to define what exactly does it mean for dominoes to fall, right? So you need to define your predicate. What exactly do you want it to be true for the number? So the inductive predicate, let me write it here. What is P of I? What do you think? What do you think? What did we do last time? Very close, very close. So you want the following to be true for every integer, right? So P of I should be just you replace n with I. Very good, right? What Justin just said. You just replace the theorem with I, right? So now it's a function that when you put in I, it returns true or false. So P of I is 1 plus 3 plus 5 plus dot 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 plus 2I minus 1 is equal to I. Let me put 2 equal because I want to make sure that it returns a Boolean. We good? Any questions so far though? Our goal, right? This thing, I'm not even saying that whether this guy is true or false yet, because that depends on the value of I, right? But our hope is to show that P of I is true for every integer. Doesn't matter. Real mathematicians use 1 equal. So if you want to look like a mathematician, this is what they do. They do 3 lines here and 2 lines over here. But since most of you are CS major, I'm going to do this. That makes your life much happier, right? Okay, now base case. You can do that as well. The base case, what is the first domino? The base case? Base case 1, right? Because if you push 1, you want to make sure that the second one falls. So you push the first one. Okay, you're gonna learn also sometimes you don't want to push the first one. Sometimes you want to push like the third one because the first and the second one violate a whole bunch of other things. But most of the time, like 99% of the time, you want to push the first one. So P of 1, it asks you to compare 2 numbers, right? So left-hand side is 1, and the right-hand side is 1 square, which we found that, 1 and 1 square, they are equal to 1, which is equal to the left-hand side. So that checks out. The first domino falls. That checks out. Okay. So the inductive step, that's the next one. Okay, the inductive step is the part where you want to show that you place the 2 dominoes close enough to each other, such that if one falls, the next one is going to fall. Okay, so tell me, inductive step, what do you assume and what do you assume and what do you want to show, right? So remember, you want to assume that the previous domino falls. This is the case 1. Gonna make the k plus 1 false as well. Right, that's what you want to assume, but don't write like that. It's so hard to read, right? It's so hard to read. So first, let's use some other variable and let's spell out what exactly is pi. So, okay, assume that pk is true. In like pk is true, but let's assume something much better, like 1 plus 3 plus 5 plus dot 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 plus 2k minus 1 is equal to k squared, right? Essentially, this is what we assume pk is true. Okay, but just don't just write pk is true. Just spell it out because it's going to help you later. Okay, and we say that this works for some k. Think about k as the number 20. You want to show that the 21 work. Okay, so we want to show WTS. This is want to show. What do we want to show? What do we want to show? Anyone? What do you want to show? Is my connection good? Because today I need to do 3G thing because 3BB ditched me on the internet. Is the connection good? Anyone? Okay, good. So what do we want to show? Okay, something like Nawat said, but let me be a bit more careful, right? So you want to show that if I add this thing up until k plus 1, right? And until k is k plus 1, and until I is k plus 1, it should work, right? So that would be 1 plus 3 plus 5. What pk plus 2? No, pk plus 2 is not pk plus 1. Plus dot dot dot. Plus, you need to be a little bit careful about the dot dot dot. Right? So for example, if k is 20, let's think about it. If k is 20, right? So that means I add up to, I don't know, 2 times 20 minus 1, right? I add up to 39. If k is 21, right? Then that means I add up to 2 times 2, 21 minus 1, which is 41, right? So that means I add it up to 2k minus 1, okay? Right? That's the 39. That's the 39, right? And then you add also 2 times k plus 1 minus 1. Right? So for a second, this is what you want to show. Pk plus 1. That's exactly what it means. You add up to 2 times k plus 1 minus 1. Right? You add up to this term. That one good, right? At least the left-hand side. All I did is I replaced I with k plus 1. Any questions so far though? What do we hope it is equal to though? What do we hope it is equal to? Why change I to k? Because k is fixed now. K is fixed. Hold on. K is fixed. This is like 20. Fixed. Like 20. Okay. Right. We want to show that if the 20th domino falls, the 21st domino should fall as well. So it's not exactly I. And also you can use I, except you use it already. Right. When I is equal to 20, but I call that 20 k. So to not be confused, I try to use different symbol when I meant different things. Or maybe that create more confusion. Why add 2k plus 1? Good, right? So let's think about it. Let's think about this. Those are all very good questions. Those are all very good questions. So let's think about what this guy means. Okay, our predicate looks like this. Okay, if we want to check that P of 3 is true, right? Okay, that's a good question. And when you're confused, I'm pretty sure there's 20 more people who got the same confusion, except they are too afraid to ask. So P of 3 is going to be 1 plus 3 plus 5 plus 7, right, is 2n plus 1. 2 times 3 minus 1, that is 6. Oh, plus 5, right? That's good, right? So P of 3 plus 1, which is what we call P4, right? Remember, your K is 3. Your K is 3. Okay, so if we assume that and we want to show that PK is true, we need to check the following, right? So this thing is 3 squared, right? So if we want to check if P4 is true, we want to check that it's 1 plus 3 plus 5 plus 7. So this is not 2k plus 1, right? Not 2k plus 1 minus 1, because that k is 3. So it's actually 2 times 4, which is k plus 1 minus 1. Are we good, Peter? Right? Your k, you define already to be 3. Any other question though? That's a good question. And we want to check whether this thing is equal to k plus 1, right? We want to check whether it's 3 plus 1 squared, because that's your k. Please define it, otherwise it's so hard to read. Please define it, otherwise. Close, except I start at 1, not 0. Close, because otherwise your first term is -1. See, edge cases. You're gonna learn it in Ajahn class. And also you should initialize the variable a and s to 0. Okay, any other question? Any other question? Any other question? We're good, right? That this thing, we want to check whether it's equal. That's why I put a question mark there. That's why I put a question mark there. Because we don't know yet whether they are equal. We know the top one. We know this guy. Actually, let me change the color. We know the blue one. But the bottom one, we don't know yet. Right? We want to show that this thing is equal to k squared. Are we good? Right? Any questions so far? Any questions so far? Let me try to go slow, because you're going to build this for me, and then we're going to go do something more fancy. Okay, now this is what we know. How do we show that the left-hand side and the right-hand side are equal? Everyone with me, right? We know the blue one. We want to prove the I don't know what this color is, pink one. Any of you from Son Gulab though? I picked the color randomly. Oh. Okay, that's not in the function and press enter. No, that's not how you do it. You just prove by example, Saran. You just prove by example, except your example is a lot because you use computer to do it. Which is actually a lot of people are doing that, right? The proof I show you at the very beginning of the class, where the paper has like 5 lines. They put it in the computer, but that's not really a proof, right? If you do it here, it's not a proof. What they did is a proof. So how do we know it? How do we know? We want to show that the left-hand side and the right-hand side are equal. How do we show it? Anyone? Help me. Put k plus 1. How do we show it? What do we know about the left-hand side? What do we know? You in algebra? Sort of, except this is your left-hand side, right? Your left-hand side looks like this. Okay. Right, this is your left-hand side. You don't know what it is. Can anyone tell me what this thing is equal to? Anyone tell me what this thing is equal to? And why? Same as before, convert everything into 2k something plus 1? Not really. Very good. Tanaka suggests, okay, Ajahn, even though I know something about this guy, let me highlight this. Tanaka suggests, Ajahn, I know something about, oops, too much. I know something about this guy. What do we know about it? We know it is equal to k squared because by inductive hypothesis, by this guy, this is what we call inductive hypothesis. Right? You have a friend who can do the problem up to the number 20. So you're going to use your friend and say, okay, my friend, what is 1 add up to 2k minus 1? Your friend knows how to do it because your friend looks like this, right? Your friend say, oh, that's easy, k squared, k squared, right? But then you need to assemble the answer because you asked your friend the smaller problem, right? So that means you have 2 times k plus 1 minus 1 left to do. Is everyone get this step? This is the most crucial step, right? The reason that we assume that it works for the following, it gives us some knowledge to do this. We are not adding to both sides. Think about this. We are not adding to both sides. What I'm doing is that I transform this guy to this guy because of this reason. Right? It's not adding to both sides though. Right? I write the whole left-hand side, but I know part of it is equal to something very simple from the inductive hypothesis. Okay. Do I care how my friend got the answer? No, I don't. That's the key. Right. The key is that you know that you are using the inductive hypothesis. That's the very important point. No. Your friend is limited to 20. Your friend is limited to k. You want to go to the next step, right? So for example, think about this. Your friend can make a rocket. I don't know. Your friend can make a rocket that's 20 meters long. And then someone asks you, okay, I want to buy a rocket that is 21 meters long. What do? You go to your friend's shop and buy the 20 meter rocket, right? And then you solder on the 21st piece, the 21st meter, right? And then you sell it for like 2x the markup. That's what you do in business. That's not scam. That's how you do in business, right? I know, just k equals 20 and add, maybe. I don't know. I'm not sure if I understood what you're saying. I know it just add k equal 20 and add. Okay, maybe you're right. Okay, but everyone get the idea, right? Your friend can do up to 20, right? So the thing that you're doing is you hire your friend to do it. You put in the last piece, and then you call it a day and charge everyone like 10 times what your friend charged you. That's good, right? That's like a good business idea. That's actually every single business. Okay, so okay, so but it's not exactly what we want yet, right? What we want is this. How do I make this look like that? Anyone help me? We're not there yet. Good. I think everyone can do this step, right? So it's plus 2k plus 1, which is k plus 1 squared. Everyone can do this. I trust you can do algebra. And then you write the summary. This is what you want, right? Equal to the right-hand side. And you say, thus, by mathematical induction, okay, 3 plus 5 plus ... plus, you can use I or N, doesn't matter now. Okay, this is a very important point. If you try to figure out how your friend makes the 20-meter rocket, he might have assembled it himself from the scratch. He might have bought 18-meter rocket and then assembled the last two, right? Or he could do something weird, but you don't care. As long as you get the 20-meter rocket, you don't care how your friends got it. You throw in the last piece and then you call it a day. Okay. What is the relation between k plus 1 square and n square? Okay, so this is exactly pk plus 1. Right, Peter? Like last time, pk plus 1. You want to show that the left-hand side and the right-hand side are equal. I want to emphasize here that p of I, this is not a number, is a Boolean, is a function that returns a Boolean. Right? You want to show that the left-hand side and the right-hand side are equal when you put in k plus 1 as I. And that's exactly what we did, right? Because if you put in k plus 1 on the left-hand side and the right-hand side is what you need to show that pk plus 1 is true. Are we good, right? And then you just show that pk plus 1 is true because of pk. Therefore, every domino is false. The left-hand side remains 1 plus 3 plus 5. The left-hand side remains whatever it is we wrote here, right? So this guy, the punchline is this guy, which is that guy, is equal to the last guy. You can ignore all the steps, right? You just care that these two guys are equal. Are we good? Now what? You're still confused? Okay. So let me try to do this again. Okay. Okay, so you want to show, right? Our goal is to show that to show pk plus 1 is true. That means you need to check the left-hand side and the right-hand side to be equal, right? The first step is you write the left-hand side, you just copy the left-hand side, right? Which is equal to this guy. And then through inductive hypothesis and some algebra, you show that it's equal exactly to the right-hand side. So that means the only thing you care about is that the first guy and the last guy are equal, right? That's what you want to show over here. And you just show that. Okay? Right? So you show that pk implies pk plus 1. And you, with the fact that you have the base case, that's why I call by mathematical induction, because you have two things, right? You have that the P1 is true, and you have the fact that pk implies pk plus 1. Therefore, you have the theorem. Okay? It's not just this piece. What are we good? Okay, so let's do the next example. You're going to become familiar. Right, you think we do that, right? That's exactly why I'm going to do the next example, because I just chose the easy example for you. Okay, so here's a theorem. Okay, so let's think about odd numbers. We know some odd numbers, right? Let's call that 1, 3, 5. What else? Next 7. Okay, I think that's enough odd numbers. Okay, so the next thing that I want to show you is to show you that, okay, let me just take n squared minus 1. Okay, we got the following, right? So that's 0, that's 8, that's 24, that's 48. What do you notice though? I can do 9 as well. 9 squared minus 1, that's 80. What do you notice? Can you do it better? Can you do it a little bit better? Can you do it a little bit better? They are all divisible by 4. Actually, it's all divisible by 8. But let's do it by 4. Doesn't matter. They're all divisible by 8. Okay. Actually, let's just prove 4. It's the same idea because my lecture note say 4. Let's make it 4 so that I can make sure that I didn't screw up. Actually, divisible by 8. Okay, so the claim is the following. N squared minus 1 is divisible by 4. So that line, that pipeline means is Oh, wait. Oh, mathematician, write it the other way. Okay, sorry about that. Let me explain the symbol. This means that 4 divides n squared minus 1. Or also, it means also that n squared minus 1 is divisible by 4 for all n in odd number. Let's say odd plus. Someone get? How do we show this? Let's show this by induction. Let's show this by induction. If I write percent, yes, you can. No. It means the following. It means this two means that n squared minus 1 is 4 times some number. Okay, divisible by means it's 4 times that number. It's divisible by 4. It means it's 4 times integer. Yes, I think it's the same symbol. What is n percent 2? Pong Chai, you probably want this. N and caret 2, not n percent 2. Positive odd integer. Actually, you know, there is also a grade scale called OSNU this term. Some courses have it, but I'm too lazy to fill out all the documents, so we still have the A, B, C, D, E, and F. No E though. Or maybe we only have A and B. Up to you guys. Okay, so this is what we want to prove, right? This is what we want to prove. So let's do it by induction. You can do it by like some other way, but let's do it by induction because I want to show you something. Because I want you to show you something. Let's do by induction. Proof by induction. Okay, proof by induction. What do we need? What do we need? What do we need? The base case, very good. Are you sure? Before we can define the base case, right? The base case, we try to show that it, right? Let's define first. What exactly are we trying to prove, right? The predicate, right? So P of I. What do we need to make sure, right? Remember, it needs to return Boolean. What do we need to check? What do we need to check for P of I? Right, that I square, that 4 divides I square minus 1. And actually, let me write this way. Write this way. I square minus 1 is equal to 4 times some number. No, it's the other way around. It's the other way around. Is everyone good, right? We want to show this. We want to show this. Essentially, I replace n by I. Or you can write this way as well. That's the same idea. Right? That's exactly the same thing. These two statements are exactly the same thing because it's essentially the definition. Actually, let me write the bottom one because it's shorter. Let's do this. 4 divides I square minus 1. We want this to be true, right? We want to show that this is true for all the positive odd numbers, right? Not for all the integers, because you know, P of true. Let's check the following. P of 1, right? P of 1. You can check that. That's 4 divides 1 minus 1? Yes, 4 divides 0, right? Because 0 is 4 times 0. So yes, but P of 2, is that even true? Because 2 squared minus 1, that's 3. That's 4 divides 2 squared minus 1? No, right? Don't get, we want to show that it's true for all the odd numbers. P of 3, that's 4 divides 3 squared minus 1, yes. Okay, everyone with me so far? Let's try I because I want to show you something. Yes, you can try, you can do 2n plus 1, but I want to show you something. Yeah, I want to show you something very important. Any questions so far though? We have the predicate, right? We have the predicate. We have the predicate, right? All we need to check for the predicate is whether 4 divides that guy. So what is our base case? What number should I plug into I to check? 1. And it's also true. 1 factorial is also 1. So you are correct either way. So P of 1, which means we need to check whether 4 divides, let's put a question mark here, 1 square minus 1, right? That means we need to check that, okay, 1 square minus 1, which is 0, and that exactly 4 times 0. So yes, right? That's how we check the divisibility. So this is our integer. So that's good, right? So now, let's do the inductive stuff. Okay. What do we want to show? What do we assume? And what do we want to show? What do we assume? And what do we want to show? Pi plus 2? Of course, let's change that to k. Let's change that to k. I know what you're saying, but let's make it more clear. Let's make it more clear, right? You want to show that if pk is true, right? The idea is the following, because we are running through the odd number, right? We are not running over all the integers, right? We are hoping the following situation will happen, which is not exactly physics, right? Not exactly the dominoes that we see each day, right? So this is 1, 2, 3, 4, and 5. So we are hoping the following, that when the first one falls, the third one would fall. And when the third one would fall, it would make the fifth one fall, right? And that's also why I did not use 2n plus 1. I want to show you that this is true even if you step like 2 times, right? Because your domain is odd number, not every single integer. Right, you can think about it as 4D domino, right? When the first one falls, it could be the next one, but no, it's the next one in the other dimension. So you add up by 2. You want to show this. PK implies PK plus 2, not PK plus 1 anymore. You can step by 2 if you like, right? The logic stay the same. Okay, so let's do this. Let's write it down exactly what we want to do. Okay. Okay. PK means, okay, so let me write it down. Let's assume that k square minus 1 is 4 times, let's call it x, right? That's what it means by this guy when you plug in k, right? For some x in integer and for some k. So far so good, right? For some k. And you want to show, what exactly do you want to show? What exactly do you want to show? Remember, you know, your friend know it up to 1,000,000. You want to show 1,000,001. What do you want to show? What? No, not that one, Chris. You want to show that pk plus 2 is true. What exactly does it mean by pk plus 2 is true? Okay, now what said the right thing? Now what said, I want to show that pk plus 2 is true. That means all I need to do is plug in k plus 2 over here in I. Right? So which means I want to show that k square, k plus 1 square minus 1 is 4 times some number, which I don't know what it is. Let's not use the same symbol for the different things, right? For some integer in I. So we're good so far with this two statement. This is the key idea, right? Anyone? So far so good? K plus 2, thank you very much. K plus 2, right? Remember, our goal is to step by 2. Thank you, thank you. K plus 2 square. Okay, sounds good so far. Let's, because I copy it, I need to copy it again. Copy. Any questions? Oh, any question? Let me pause here a little bit before we go on. Any question? Okay. What is K? K is your friend's shop, right? Your friends, your friend is a guy who know that 21st, let's say, let's think K is like 19. Your friends know 19 square minus 1 is divisible by 4. We want to show that 21 square minus 1 is divisible by 4. This is your friend. This is you. That's good, right? So if when you get confused, think about K as a fixed number that you want to show that the next one gonna work. Okay, let's do this. I paste this. Technology, help me. There. How do we show this? Why? Oh, because we want to show that this thing is divisible by, because we want to show that K plus 2 square minus 1 is divisible by 4. Right? And by definition, that means this guy has to be 4 times some number, and I call that number Y. I don't want to call it X because I use X already. Okay, how do we show it? How do we show it? Right? That there's no sum to replace anymore. There's no sum to replace anymore. Can you somehow use your friend, right? That's the goal for this class. Use your friend. And charge 10 times your friend tries and make the profit. So how do you use your friend? Right? Your friend knows something very limited. If you give him k squared minus 1, he knows something about it, but we do not have k squared minus 1. Good. So let's do like Chris suggests. Let's expand this. Let's expand this. Because your friend knows something like this, right? So let's rearrange it such that it becomes something your friend sort of know, plus some other junk that we might need to work on it, right? So you get k squared plus 4k plus 4 minus 1, right? So this is the left-hand side, which our secret hope, right, is to show that it's equal to 4 times something really long. 4 times some number. This is like secret hope. How do we do it? How do we do it? Anyone has a good suggestion? Does your friend know anything about this? Very good. Right. Risky suggests, Ajan, there. This is what I can use my friend for. Right? My friend is the following. My friend is the guy who knows how to do k squared minus 1. And I have k squared minus 1. Why not? I'm going to use my friend. What do your friend know about k squared minus 1? It is equal to 4 times some integer, right? So this thing is by inductive hypothesis. This is important, right? This is important. By inductive hypothesis, It is 4x. Right? Actually, let me just remove this. It's 4x, right? But then you still have some other junk, right? Like 4k plus 4. Factor out the 4 and we are done, right? So this is 4 times x plus k plus 1. And then that means 4 divides k plus 2 square minus 1. Right? Think about this. You use your friend. You don't even need to know what x is. You don't even need to know how your friend find x. As long as you know that your friend gives you some 4 times some integer, you can trust your friend on this one. Are you get? This is a very important power of inductive hypothesis. You don't care how your friend gets the answer. As long as he has the answer, I can work through it, and then I charge people 10 times the price. Haven't get? Haven't get? Right. Except we can't do this virtually. Okay, you never do business, right? You never do business. Try start your shop. This I highly recommend everyone sell stuff online. One time in your life, sell something online, or even sell something on like game online. That works too. Because that's how we do business. Justin, what should we sell? I don't know. Yes, I mean, go and borrow your friend's answer. Exactly. I say charge 10 times the price because I know after the end of the class, you're not going to remember anything, but you're going to remember the phrase charge 10 people 10 times the price. That's why I said that. And actually, that's how people do the business. Right? Your friend is just a cheap labor. And then don't spill the secret on how to add the extra step to your friend. Okay, so let's do this. Let's write the summary, right? The summary, because we have the base case, and I want to point you something, right? By mathematical induction, therefore, n square minus 1, oops, 4 divides n square minus 1 for all n in odd number plus, right? Because we start at 1 and we go up by 2. So far, so good, right? Any questions so far, though? Any questions so far? I think you see the theme, right? The theme is you don't solve the problem yourself. You let your friend solve the problem, and then you do like very small additional at the end. Then you should be happy with the 10 times the price that you get already. Think about your cell phone. How many components are there? Modern supply chain is needlessly complicated. Think about your computer. How many countries, how many factory actually make all the parts on your computer? Hundreds or maybe thousands of factory that made all the parts on your computer. Each one charge a markup, which means if you try to make a computer from scratch, I mean, you dig up the sand, burn the sand yourself, do the lithography on your chip and so on. You can probably make it like 1,000 times the price. You can price of the real material is probably less than $1, right? Because you don't really pay for it. You dig up the sand and you do all the things. Right. Every single supply chain works like this. Contribute your own GPU of sand. Okay, so the word that you should look for is DIY lithography. You're gonna be surprised like how much sunk cost lithography. It's just almost impossible. let me say that it's almost impossible to make your own IC at home. But the guy who did it, I'm gonna say that it's easy, but look at all the equipment he has. Oh, any question? Any question? Any question? I think this is good, right? But I want to point out one very important thing about this example. That's also the reason why I didn't use 2n plus 1. Okay, let's think about this. This step over here. If somehow your friend, a very good friend, can show that this thing is true when k is equal to 2, right? This thing is true when k is equal to 2. Then you can show that all the even integer is going to work, right? Think about this. Think about this. All the ones, this is the first one, the third one, the fifth one, they are placed close to each other, right? Because if one falls, the other one is false. But if you think about it, the number 2, the number 4, the number 6, the number 8 are also placed close to each other because that's what it says, right? If you have k, you have k plus 2 for free, right? If you have k, you have k plus 2 for free. So that means these people are actually really close to each other as well. That is if you can somehow make the second guy false, make the number 2 false, every even number is going to go as well. Except you know that's false, right? Because we tried that before. Except that's false because we tried that before, right? So this is the situation where you can make this guy false. Okay, this guy, yes, you made sure that they are placed close enough, except this guy is super glued to the floor. This guy is super glued to the floor. You cannot make them fall. So that means you cannot make the whole chain fall. Are we good on this analogy, right? This is this is like, this is why I said it's not enough that you only have the inductive step. You need the base case, right? You need the base case because you know that if you have the case one, I didn't say what the number k is. It could be 21. It could be 20. If it's 20, then it's going to make the 22nd false. If it's 21st, it's going to make the 23rd false, right? So that means all the even number, they're placed close to each other, except you cannot make the first one false. So that means none of them false. Not exactly mathematically correct, but I think you get my idea, right? That you need a base case as one as well to actually make everything false. So this thing false. This thing is super glued to the ground. You cannot make it false. Are we good? Maybe you can try. You can try. K squared plus 1 also has some interesting properties. You can try it, and what kind of property you see, then you can try to prove it. Anything? Anything else? Anyone? If not, we're gonna take 10 minutes break and you should come back at 15:05 and we're gonna do some real math. This thing gonna blow your mind. And I think it's gonna show up on your on Ajahn Kanat's homework as well. 15:05, right. Yes, what about it, Pete? Maybe you can prove that, Saran. About number 8 in assignment 2, you mean homework 1, right? What is that question though? Homework 8. What was that question about? I don't remember what's question 8. Oh, profit. Okay, what's up about it? That sounds like a scam, right? You should know by now it's a scam. I want you to prove that it's a scam. That means such an algorithm cannot exist. That means such an algorithm cannot exist. I want you to show that this is a scam, which I think you're gonna see that in your life, right? Someone gonna tell you to look at the graph, the technical graph. That means this graph makes some triangle that the amplitude is some Fibonacci and whatever they bullshit is. Right? It's a scam. No, just do it. Make it sound more like a mathematician. Right. So the contradiction is when everyone wins, something gets it's really wrong. If everyone wins, something went really wrong if everyone wins. Okay. Right. So good, grit. That means you are learning something from this course. Except when you try to tell your parents, when you try to tell your parents, what did you learn in this class? You can tell your parents that I learned that I cannot place the rock this way. And then your parents are gonna be, what? I'm moving my kids from MUIC to some other place. Theorem sum means the following that the money cannot be generated from like nothing. Right. So for example, if I play with you, if I play with you, if I play, I don't know, a poker with you, if the if we start with 100 baht, right? Eventually, whatever I do, I could, if my money is 80, your money has to be 120, right? So it has to add up to a certain constant. That's what it means by zero sum game. That means my all the profit and loss, they need to add up to zero. It's not the money, it's the all the profit and loss need to add up to zero because there's a conservation of money, conservation of cash, not conservation of money. There's no conservation of wealth though. There is a conservation of cash. Wealth is what you bullshit, like how much you worth. But there's a conservation of cash. Right, conservation of energy, it means the energy at the beginning and at the end are the same. So zero sum, that means the total money at the beginning and total money at the end are the same. Continues. But this is not the conservation of wealth though. Let me give you the difference between wealth and cash. Cash is like Thai baht money, right? Conservation of wealth, there's no conservation of wealth because, so for example, you buy a Bitcoin, you never use Bitcoin to do anything, but you say that Bitcoin worth a million. But whether you can actually get the cash for a million for that Bitcoin, that's another problem. Right? So you claim that you have the wealth of a million baht because you have a Bitcoin, but whether you can make that into cash or not, that's another problem. That actually happens a long time ago in Thailand. If you are old enough,ปี40นะต้มยำกุ้ง crisis. Everyone believes that 25 baht is $1 because Thailand said so. Until Thailand like, nah, I'm not gonna do it because I lose too much money already. Go read or watch some YouTube about it though. It's a fun story on how broken the system is. Why Tom Yum Goong though? Because it already the effect is mostly Thailand. The effect in Thailand is the strongest because we have a peg money. Go watch YouTube about it after class. Try watch the one without political agenda, only the economic side of so many political agenda way back then. It's a fun story. I think no one went to jail though. No one went to jail. Even at the end, no one went to jail. Jail is only for poor people, not for rich people. I think no one went to jail. I think if strictly less than 3 people went to jail, that's I'm sure about it. Some people become a politician today. Some people live abroad until the case ran out of the limit of statute of limitation ran out, and come back to Thailand, and some politician went and hugged him. You go find out who. And if you cross the Sathorn Bridge, there's a building. That building, there's an abandoned building. That building has to do with 2540 Tom Yam Goong crisis. May I ask about your anecdote? What's anecdote? Don't believe everything I say though. Just verify it yourself, including my proof, like your history. What about it, Chris? Right, but there are two school of thought, right? There are two school of thought. The system clearly sucks for you. The system clearly sucks for you, right? The younger generation doesn't really see a hope on how you would like step up the society, right? Yes, I'm from Songkalap as well, but young generation don't see how they step up the society, right? It's like, oh my God, if you do not have the connection, if you do not do something like gray area, there's no way for you to climb up the society. That's why there's a lot of protest from the younger generation. Okay, so there are two school of thought. The first one is just move, just change the country. That's easy, right? The second school of thought is, okay, I'm gonna fix it somehow. I don't know how. There are two school of thought. Not 20 yet. Doubtful. I don't know. Maybe we can. The time scale of the change is typically on the order of 10 years, not 20. Okay, now people in this class, you don't do the homework, you watch Netflix, right? Last time, what was the movie? Last time was what? Hitchhiker to Guide to the Galaxy. Now is what? How to become a tyrant. So, so you watch those grown up and promise to yourself, when I grow up, I'm not gonna become like them. Then I'm gonna be so proud of you. Okay? You can see bad example, but learn from it. I'm not gonna become that kind of asshole when I grow up. Okay, there are a lot of people when I was a kid, and then I see them, and then, okay, I promise myself I'm not gonna become them. That's like bullshit. Okay, so let's go back to math because it's time to do math, right? You are here to learn math, not politics. Let's do math. Or maybe, Risky, you haven't said that yet, that this Thursday going to become a holiday. That's actually a holiday some when, I think it's October somewhere, an actual holiday that they just add up They just add on, not add up. They just add on, but I don't think it's going to be holidays for you guys. No, 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 not this Thursday. Next month, someday. Some Thursday next month gonna be a holiday, a real holiday, not because I got arrested, but but an actual holiday. Okay, but it's not gonna be a holiday for you guys because I'm gonna do makeup right on that day. Okay, so let's do math. Let's do math. Let's do math. This is, you may look at this problem and you may say, okay, that's clearly not a math. So let's do this. Let's do this. You have a grid of 8 by 8. Wait, actually, I have technology. 2 seconds. I can add a grid paper there. Technology. Good. If he got arrested, I think they might allow teach online from jail. 1, 2, 3, 4, 5, 6, 7, 8. So an 8 by 8 grid. 1, 2, 3, 4, 5, 7, 8. Okay. You have an 8 by 8 grid. Jail might have better internet. That might be true. Right now, I do not have the real fiber optics that I used to have. I called them 6 times already. Okay, so let's do this. Let's do this. You have an 8 by 8 grid. This is an 8 by 8 grid. Okay, and I want to do the following. Okay, so let's say you want to place your statue. You become really rich. You place your statue over here. Okay, and the next thing you do is you want to fill out the grid with an L-shaped trinomials. It looks like this. Okay, let's think about this. Is this even possible? Guys, please do math. Please do math. Please do math. Okay, so you have a garden, right? You have a grid, and then you get rid of one of the grid, and you too. Get rid of one of the point of the grid, and then you want to tile the grid with this, with an L. The question is, can you or can you not? Right? The first thing that you should check, okay, Ajahn, you claim something funny. Let me check first that the leftover is divisible by 3, because at least if it's not divisible by 3, there's no way you can do it, right? So, okay, let's do this real quick. 8 square minus 1, that's 63. Right? Okay, good. This is divisible by 3. But divisible by 3, that doesn't really mean that you can place it. So for example, this thing is divisible by 3, 3 by 1. There's no way you can place this inside, right? There's no way you can place this inside. Okay, so let's try. Can I give you 2 minutes to try? I give you 2 minutes to try. I'm gonna try it too. Let me use color as well. Fast while play Tetris. Oh, is that a challenge? You guys don't know, right? That we used to play Tetris like crazy in 1409. It was 1409, not 1502, because 1502 comes with COVID. And I actually ranked first on on. Oh, Kotu lose to me. Kotu lose to me, risky. But I lose to Bay though. Bay wins. Bay wins by a large margin. Okay. Let me try. Let me try. Okay. 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 I just talked to Kotu last night though. Wait. What did I screw up? Oh, I screwed up that. Sorry. I forgot that guy. Mm, Let me fix it. You can see that it's a bit problematic if I did not plan ahead. Yay, I did it. Yes, the center one is blocked. I think you can see that we can do things like this. Wait, what did I miss? I just clicked it, right? Did I screw up something? Let me place. Right, I just did it. No, I only have L. I did not do anything funny. Right, you can try. You can try. You can. There are multiple solutions. I think. Yeah. I think everyone convinced, right? At least I drew them for you that you can do it 8 by 8. You can do 8 by 8 at least. You can do it 8 by 8 at least. Okay. Anyone succeed? Well, you can do that as well. You can do that as well. So let's do this. Let's do this. Let's think about this. Let's think about this carefully. I claim the following. Notice contain grid paper. You're gonna become an expert real quick. Okay, so theorem. Okay. Theorem is that 2 to the n by 2 to the n grid is L tilable. By L tilable, that this is an unofficial word though. It means that you can fill 2 to the n grid by 2 to the n grid with the centerpiece missing. Is L tilable. By L tilable, it means that you can fill it with L shape trinomials. So that's good. This is my theorem, and this is what I did. Okay, so I claim it's not just 8 by 8. You can do it, I don't know, 1024 by 1024 if you like. Okay, so how do we do it, right? Remember the goal here, the theme for this part is to use your friend. Should we determine the area each tile cover and the total area? Right, close, right? Because, but it's not quite because we just show, right? The fact is divisible by 3 doesn't mean it's tileable, right? So this thing is divisible by 3 because 3 by 1, that's 3, but you cannot put an L there. So Not just the fact that it's divisible by 3, but it's guaranteed to be divisible by 3, that 2 to the n by 2 to the n minus 1. You can show that easily. No, let's do the following. Let's do the following, right? At the end, you know that you're gonna need to make a predicate and so on. Let's write the predicate. Let's write the predicate. So let's prove this. Okay, let's prove this. You need a predicate first. What is your P of I? Actually, let me put for all n greater than 1. Greater than or equal to 1. Otherwise, it's meaningless, right? What's your P of I? Can anyone tell me? What's your P of I? Can anyone tell me? Good. We just copy the question, right? And then change n to I. That's typically what happens, right? So you say that 2 to the I by 2 to the I minus the center without the center piece, without center. Now let's say with the center piece missing, with the center piece missing is L tolerable. Is the area of L rugby? Doesn't matter. But yes, let's make it regular grid to make your life easy. Right? I just show you that you can do it, at least for 8. Okay. So far so good. Let's do the base case. What do you want to show in the base case? What do you want to show in the base case? I equals to 1, good, right? Because we want to show P1, which means we want to show the 2 by 2, right? 2 to the 1 by 2 to the 1 with the centerpiece missing. Is L tolerable. It's weird. Today, I don't get complaints about handwriting anymore. I think you guys used to it, right? Not that my handwriting gets better. Not that my handwriting gets better, but you got used to it. Okay, P1, it means that 2 by 2 grid with the centerpiece missing is L tolerable. Tolerable means you can feel it. You can feel it. Yeah, this thing is L tolerable. That means you can feel it with L. Right. Okay. Okay. That means you can fill the whole space with L. So how do we show it? How do we show it that P1 is true? How do we show it? If you think about it, there are only 4 cases, right? Because the centerpiece, there are only 4 cases, which they are rotation of each other. You can draw the 4 cases, or you can draw one and say that the rest are the same, right? So, oops, there are 4 cases. So you can fill it like this, like this, like this, like this. These are all the cases. Okay. So we show that, okay, 2 by 2, we can always do it because there are only 4 things you can do, right? That's easy, but if you get to like larger thing, then it gets harder. Are we good? Everyone, are we good? How do you write that in math? This is math already. Drawing picture is also math. The math symbol is there to make yourself to make explaining yourself more precise, but if you can make it precise by some other means, please do so. You can do that. For this one, you need to define a whole bunch of symbols, right? Then it's become much more confusing because you only use it one time. Yes, but please avoid that. Be as short as possible. I saw some people who later become a really good mathematician though. Who later, he wrote an essay to me at the very beginning. There's an introduction, body, and conclusion. Just like how you do easy one. But please don't. He later become a really good mathematician, but don't. Okay, good. Right now, that's the inductive step. That's the inductive step. Okay, let's do this. The inductive step. Okay. So, what do we assume and what do you want to show? What do you want? What do we assume and what do you want to show? Assume assume mi. We can feel bigger group. Oh my god! I know you guys have the right idea. So let's do this. You, what is the assumption, right? We want to show that pk implies pk plus one. What exactly is pk? What exactly is pk? 3 divides? No. It's not just divisible, right? This is much stronger than divisible. This is the fact that it's tileable, right? So let's assume that 2 to the k by 2 to the k grid with center p missing is L tileable. Okay, 2 to the k by 2 to the k for some k, of course. What do we want to show? Want to show that, what do you want to show? You guys tell me, what do you want to show? Very good. We want to show the 2 to the k plus 1 by 2 to the k plus 1 grid with the center missing, the center piece missing. Is L tileable. Okay, let's think about this, right? I think this part is clear. But the key part is how would you divide up the work so that you can throw it to your friends? So let's think about this. 2 to the k plus 1. Let's make it 8 by 8. 1, 2, wait. I have a grid paper, so let's make it 2, 3, 4, 5, 6, 7, 8. Okay, good. Right? So let's think about this. If 2 to, so this thing is 2 to the 2 plus 1 by 2 to the 2 plus 1, right? With the centerpiece missing. Let's do this. With the centerpiece missing. Okay? So, but you have your friends, right? But you have your friends who know how to do 2 to the 2 by 2 to the 2, that which is 4 by 4. Your friends know how to do 4 by 4. What would you say to your friend? This is a key idea. This is a key. Help me do it. Help me do it. What would you do? What would you do? What would you do? Borrow his work? Good. But his work right? It's only 4 by 4, and Saran suggests something very simple, right? Saran suggests something very simple. Okay, Ajahn, I can see I just need 4 friends, which is a lot, given that you're a CS major. So, so you have 4 friends. You have 4 friends, right? All your friends can do 2 by 2. Can do 2 by 2, can do 2 by 2, right? But your friend gonna reject this. Now tell me why. What can your friend do exactly? What can your friend do? What 4 by 4 looks like that he can do? Right. He at least need a piece missing. Right. But if you do this, okay, this thing is your friend gonna say, okay, maybe. Right. But this guy, wait, no piece missing. How can I do it? It's not even divisible by 3. What are you asking me, right? This thing is like, nah, of course, nah. This thing is so nah. Right. Think about this. You cannot do it, right? You cannot do it. Right. The top part, at least he has a piece missing. At least it's divisible by 3. At least it's divisible by 3, right? The top left, this thing is at least divisible by 3, but the rest, they aren't even divisible by 3. What are you asking me to do? Any good idea though? Any good idea? Any good idea? At least get everyone to be divisible by 3. That means you take away 1 piece from everyone. How do you take away 1 piece from everyone? What do you notice though? What do you notice from when I did it? What do you notice? You want to take away 1 piece from everyone, right? Because at least you want to take away 1 piece. Let me copy what I did real quick. 2 seconds. Let me copy what I did. You notice something. Do you notice something? How would I take away? How would I take away 1 piece from everyone? Easy way. How do I take away 1 piece from everyone? -3. Make 1 overflow 2, then next one overflow 1, then have a what? -1 from each piece. What kind of choice do you have? What game is this? The game is to put an L everywhere, right? Why can't we just remove 1 from each quadrant? Yes, we can, but how? Take away 1 piece of the L. Okay, I think everyone gets the idea except you say the wrong thing. So I'm gonna do with what Thanatat said. Why can't we just remove 1 L from each quadrant? What that it means, what he meant is the following. How about if we already place this, right? Then the goal, right, is to tell your friend, this friend gonna take away this chunk, and I say, don't put it there, right? So your friend, one guy gonna get this, the other guy gonna get this, the other guy gonna get this, right? This guy gonna get this, and this guy gonna get this. At least they are all divisible by 3, right? At least, because I take away 1 piece, because I know, okay, if everyone, right? If everyone come back to me with each of the solution, right? Everyone come back to me with each of the solution. I put them together. Then I'm gonna have the centerpiece missing, and with a place where I can place my final L and charge people 10 times. I'm good. That's like really smart, right? I hire 4 people. Okay, this time I need to charge people 40 times the amount, right? Is everyone good? By placing an L and then divide the work, then at least your friend has something divisible by 3. Any questions so far, though? Any questions so far? Any questions so far? right? If I place this, right? Think about this. Each quadrant has one piece missing. Any questions so far though? Any questions so far? Is that what you meant, Saran? Because you typed this 2 times, except I have no idea what you meant. But I think this is what you meant, right? Place one out in the center and everyone gonna have one piece missing. Any questions so far though? Everyone good, right? Okay. Everyone good? Everyone good. But there's one problem. Can anyone tell me? Your friend gonna reject this. Your friend say, no, I cannot do it. Why? We are so close, right? We are so close. Exactly. It's not the center, right? That's why I try to avoid answering that question. Your friend said, no, this thing is a no, but this is a yes, right? I can do this, but not that. Extend the whole, right? Your friend gonna say no because your friend say, okay, it has to be the centerpiece. Your friend sucks, right? No. No, because your friend really sucks. Your friend doesn't know how to do this. What would you do? Tell me. I know. I demand one joke from you. What would you do with your friend? Right. No. Unfriend. Very good. You unfriend. But you need 4 friends though. You can unfriend them. Okay, let's get a better friend. Let's get a better friend. Let's get a better friend. Let's see. Let's see. What kind of better friend would you need? Right? Your friend sucks because your friend can only do this. Because your friend says only the centerpiece. What would a better friend do? What would a better friend do? He can still do smaller problem, but better friend can the better friend that can take this problem that can take this problem. Split it down further. No. Think about this. You want a better friend, right? That's your goal. You want a better friend because your friend right now cannot solve your problem. What would a better friend be able to do? What would a better friend should be able to do? What should better friend be do? Can do? What should a right. We want a better friend, right? The current friend can only do this. This is your friend. Current friend. Let's make ex friend, not current friend, ex friend because you fired him already. Let's call this guy ex friend. What would a better friend be able to do? What should the better friend be able to do? Can we just rotate it? No. No matter how you rotate, you cannot get it to the corner, right? Very good, right? A better friend should be able to do this with a piece missing, any piece. Are we good? Right? If you have this better friend, right? If you have this better friend, your problem is solved, right? Because now you can throw away your problem. Are we good? Are we good? This, I'm trying to teach you something very important, that the better friend you have, the easier your life. You try to share the screen with me. Okay, so your friend sucks. We're gonna change your friend, but to change your friend to this guy who can solve any problem, you need to change a whole bunch of things. So let's go back and change a whole bunch of things, and then we're gonna come back and solve this. Are we good? Is everyone good with the concept though, that you cannot do this exactly because your friend sucks, right? If you have a better friend who is more powerful, If you have a better friend who is more powerful in solving problem, then your life is better, right? Because you control more kinds of problem at him. Okay, so let's change it. The better friend that you like is the guy who can solve it with any piece missing. Okay, with any piece missing, that means you kind of need to change the theorem a little bit, right? So in at the center with any, let me write any, right? Actually, it's a piece missing anywhere. Right. Think about this. Sort of cheating, but if you look at this, if you can solve it, if you can solve harder problem, this is actually harder problem, right? You try to solve it with any piece missing. That means if it's a center, we can solve it as well, right? So induction is kind of weird, such that the more general the theorem, the easier it is to prove, not the other way around, right? Because the more general the theorem, the better the friend you have. Are we good? This is the point that I'm trying to teach you with this example, beside the fact that how to divide the work, right? Right. Right. So to do that, let's make the problem a bit more general, right? So we say that we're gonna solve 2 to the n by 2 to the n with any piece missing. That includes the center and that includes the corner. Okay. So let's change this. Okay. So that means if we everyone can see, right? If we can solve this problem, we get the center one for free. Okay. And as Risky was saying, this thing is not specific to the centerpiece, so we don't need to change the base case. Are we good? Okay. Right. That's the idea. That's the idea. The more general the theorem, the easier it is to prove. Oh, wait a second. Another channel, Fifth the Brit. Go watch that channel afterward. Okay, let's get back to math, right? So now our theorem has changed to something more general, which means this, we get a better friend. We get a better friend, but also we get a harder problem, right? Because we need to do this not just for the center, but for any piece missing, right? Not only that we get a better friend, but we get a harder problem as well. But sometimes your friend get a lot better than the problem that you need to solve, and you can solve it. Okay, so that means this thing doesn't have to be at the center anymore. It could be here. It could be here, right? That's good. Does that create a problem? Is that one good, right? So now we have a harder problem because you have a better friend who can solve 2 to the k by 2 to the k with any piece missing anywhere, right? But then the thing that you need to solve is 2 to the k plus 1 by 2 to the k plus 1, but not the center piece missing, but any piece missing as well. Okay, so far so good. And we learned the trick already on how to divide up the work for your friend, right? Such that you at least want everyone to be divisible by 3. So you're going to place the L piece at the center like this, facing away from here. We're going to write that later if we have time though. Okay, we're going to place it L facing away from the missing piece over here. Right? And then we can divide the work, right? Because this time when you divide the work, your friends know how to do it. Your friends know how to do it because everyone say, the first guy gets this. Yes, I can do it. The second guy get this. He said, yes, I can do this as well. The fourth guy have this. He said, yes, I can do this as well. And the fourth guy get this and said, yes, I can do this as well. Is that one good? Right? The fact that you have a harder problem, but your friend gets a lot better make your problem a lot easier. Can anyone sees it? No, right? The same trick works only if that you make your problem more general and it's become much easier to solve. Any questions so far? Though? Any questions so far? Can we change the problem on exam? Typically, I don't put the question that you need to change the problem on the exam. Right, this is the concept of divide and conquer. Because this kind of thing, if you see it, you see it. If you don't, you don't. So I'm not going to put it on the exam, something that you need to change the problem. But I want you to see that the more general the problem, easier it is to solve by induction. Okay? Because you have better friend, but you need to solve much harder problem as well. So did we take away 4 pieces? Yes, by placing the L over here. And then have the rest of people fill up this grid, that grid, that grid, and that grid. Each one of them has 1 piece missing. Right? Now you hire your friend 4 times. How much you going to charge? You're going to charge 100 times. Okay? I know at the end of the class, Justin, you're not going to remember how to do induction, but you're going to remember how to charge people. Any questions so far? Any questions so far? So let's write it down. Let's write it down like properly. Let's write it down properly, right? This is the idea. Right. Yes, this is related to recursion. Is this essentially recursion? So when you think about recursion, right, you get your friend to do it. So you call the function with the smaller argument, and eventually you're gonna hit the base case. That's what you hope. You don't even care how your friend do it, right? I don't care how my friend fill up the 4x4. I don't care as long as he give me the 4x4. Okay, so far so good. That's the whole point. You don't care how he does it. As long as he does it, then we're good. Okay, so let's do this. Let's write down. Let's write it down. Okay, so let's write the proof here. Okay, consider 2 to the n plus 1, oops, not n plus 1, k plus 1, right? By 2 to the k plus 1 grid with a piece missing. Okay, and we can say without loss of generality, right? We get all the idea now. All we need to do is write them down. This is how you should do the homework. Get the idea, then write them down. Don't scratch the idea on the paper as well. So you should write it like 2 times. One of them is scratch paper and the other one is the actual proof. Without loss of generality, we're going to put the missing piece on the top left. Okay. Let the missing piece be on the top left. Okay. We can place and our trinomials in the center. You can draw a picture as well in the center, facing away from the quadrant with missing piece. Okay, so if you explain it by word, you're gonna get a bit confused, right? So you can draw some examples. So example, that is last night I watched How to Sound Like a Mathematician. You use the word namely. Namely, uh, namely, if you have something like this, then this thing is 2 to the k plus 1 by 2 to the k plus 1. Okay, and you write the division a little bit. And this is the missing piece. You place an L over here. Okay. Namely this picture. Okay, that's good too. Then we can divide up the grid into 4 of 2 to the k by 2 to the k grid, each with a piece missing. Right? So once you do that, this is what happened. This is 2 to the k. This thing is 2 to the k. Okay. Uh-oh. No. This Thursday is not a holiday. So with a piece missing, and the that's good, right? I just wrote what I explained to you earlier. Okay, then how do I know that I can solve it? Well, I can use my friend, right? By inductive hypothesis, each quadrant is L tilable. That's the whole thing is tilable. That's the whole k plus 1 grid with a piece missing is L tilable. And then you can write a conclusion, which I trust you can do it. So that's good, right? So I want to show you that we can brainstorm the idea that looks like this. And then if you try to explain it, sometimes draw a picture that works too. Okay. So we prove what we need. Any questions though? Any question? Any question? We are running out of time. Any question though? Anyone? Any question? So you learn two things here, right? That you can. I don't know. I need to click something on Canvas to make Pawan and not to be TA, which I haven't done that, and then they can grade it. It's a lot though. There are like 60 of you or 80 of you. I don't remember. A lot. A lot of you. There are a lot of you. So it's gonna take a while for them to grade. They could divide up the work somehow though. Oh, that's easy. That's one click. I can do it right after class. We can do it right after class. Okay. So any question? Any question? If not, we are going to call it a day. And let me remind you that homework 1 is due on Thursday. Please do it. It's going to be fun. Okay. So see you on Thursday. It's not a holiday. Hopefully I don't get arrested. Okay. Bye, everyone.
Thank you for the class, Kapachan.
Thank you, Kabajan.
Okay. Let me stop the recording. Yes, I did stop it. What about it, Chris?
So it's about the absolute value question in the assignment again, because I did it yesterday.
Uh-huh.
I'm not really sure if I got this
What did you
one
do?
right, because it just looked dubiously simplistic.
It should
So
be
basically,
simple.
so as we all know that the absolute, so basically, as we all know that the absolute values can be as like in the absolute value, whether that value is positive or negative. Once you did absolute on that, it will always come out positive, no matter what.
Oh, now I know what you did. Let me remind you one thing. I'm not asking that both sides are positive. I'm asking that both sides are equal.
I know. That's why it's
So-
not 2 cases from me, it's 4 cases from me because they're
It
like
should be
two
4
variables.
cases. It should be 4. But you can lump it up somehow, but 4 cases is fine.
Yeah, because 2 cases, there's no way it's gonna fit. Okay, then I think I should have already been on the right path. Thank you.
Okay. Yep. So just be careful. I'm not asking that they are both positive. I'm asking that they are equal. Yeah. So show that they are equal, then I'm happy. Okay. See you on Thursday. If you have problems, scream on Discord and someone gonna answer you before I do. Anyway, bye everyone.